Hi, my name is Christy Gross, and today I'll be talking to you about RAM analysis in terms of digital forensics. So, RAM capture is the process of capturing live memory from a running computer system. RAM analysis consists of performing forensic analysis on data gathered from the live computer. After conducting a memory dump on any live machine to capture RAM, that memory image can be used to determine information about multiple things on a computer system, including the running programs, the operating system, and the overall state of the computer. It also helps you locate deleted or temporary information that you might not otherwise find on a normal image. Until recently, RAM analysis and capture was not a mandatory step in investigations and wasn't even considered an important step in triage situations where analysts were trying to gather forensic data on site. However, with new tools that allow entry into locked systems and with the growing importance of temporary files, RAM analysis is quickly becoming a pivotal and mandatory part of the digital forensics process. Volatile memory access, which is also known as live forensics, is useful in law enforcement situations where data would be lost by powering off a suspect machine. In the past, this is how most images are taken. The officers on site would shut down the computer, bring it back to the lab, and then an image would take place, and a lot of temporary data is lost by doing that. The longer a machine is turned off, the more data becomes lost and unavailable to forensic analysts. However, if you're using a live capture of the RAM memory, you can find some of the following things. You can find processes, network connections, open files, configurations, encryption keys, open or active registry keys, exploit-related information, zero-day attacks and rootkits, and also kernel-level structures. In terms of RAM analysis tools, there are a lot of brand new tools that have become available within the past decade. Some are free and others you need to pay for. And these serve to better help forensic analysts to capture RAM data. There are three specifically that are highly useful, which a lot of people are actually using, a lot of forensic analysts are actually using in their investigations. The first one is FTK Imager. This is a Windows-based program capable of capturing local drives and also local RAM. You can then look at it in another FTK program. Volatility is a Kali Linux tool which allows you to analyze RAM from a memory dump image. And then finally, there is a program called Win64DD. It's also known as DumpIt. And this is a program that can be installed on any Windows machine in order to capture or dump local RAM from that computer. DumpIt is often a tool of choice for triage forensics experts, largely because it can be run directly from a USB key. This means that you're not installing any outside software onto the machine that you're trying to analyze, and therefore you're maintaining the forensic integrity of the machine. So in the following RAM analysis tutorial, we're going to be following a couple of steps. The first step is to locally capture RAM using FTK Imager and also the DumpIt program. And this would be done in a triage situation in the field. Most likely you would be using the DumpIt program instead of FTK Imager because FTK Imager does have to be installed on a machine in order to use it, whereas DumpIt does not. The second step is going to be looking at the captured RAM data to view the output of the RAM image file, and this will help us to gather additional information from the system. So go ahead and launch your Windows 8 virtual machine. I have mine set up here. It should already have Access Data FTK Imager preloaded onto it. We're going to go ahead and launch this program. Once this starts, if we click File, we can see a number of different options. The one we're going to be using is Capture Memory, and this is going to capture the current RAM, the current live memory of this particular virtual machine. So go ahead and click Capture Memory. You're going to give it a destination path. I'm going to put mine on the desktop. The destination file name, it will automatically name it memdump.mem, and that's fine. In this case, we don't need to include a page file or an 81 file. We can just click capture memory. This will take several minutes depending on how many programs and how many processes are currently running on this live machine. There are not many running on this machine, so it should not actually take a large amount of time. Once the capturing process is complete, you'll have a status here that says the memory capture has finished successfully. Go ahead and click close, and go ahead and close the image or program. And here on the desktop we will see our memdump.mem file that we just created. This one is 2 gigabytes in size. In order to view the contents of memdump.mem, we can open it inside of Forensic Toolkit, or FTK. And this will allow us to view the various processes and programs and registry keys and other things that we might want to look at. So we'll go ahead and start a new case and click OK. Go ahead and fill out the following information: the investigator name, the case information, and the case name. And then go ahead and click Next. You can skip this next page and then just go ahead and click Next. And finally we'll get to the Add Evidence page. And then go ahead and click Add Evidence. And then the kind of evidence that we're going to be looking at is an acquired image of a drive, which is automatically selected. So go ahead and click Continue. And then from the desktop, locate your memdump.mem file. It'll ask you to give some information about the evidence. Then click OK. Then click Next after you see that your evidence has been added to the case. And then click Finish. And it will probably take a few minutes for the file to be loaded since it is relatively large in size. You'll receive a window that will tell you the current status of the files that are being processed for this case. Once the file has finished importing into FTK, we can go ahead and look at the contents by going to Explore and then clicking on the no name-unknown. And these here are the contents of the RAM or the live memory on this computer. As you can see here, the majority of it is SLAT or free space. However, if we were to look through each of these individually, we would see that in some cases there are contents listed inside of each of these. If you're looking for particular pieces of data, such as processes or programs that are currently running, you might have to look online to see where in the live memory those would be located. So go ahead and close this. Now we're going to look at the program called DumpIt. And this is one that's highly used by current forensic analysts in the field, as you can load it directly from a USB if you'd like. So go ahead and open up the MWMT folder on the desktop. And inside you'll see the DumpIt application. Go ahead and run that. It's going to ask you if you're sure you want to continue. By typing yes, this will tell it to proceed with the live capture. We can see here that the destination is just going to be in the same folder where this program is located. So now the program is going to begin the live memory dump, and it will alert you once it's finished. Again, this may take several minutes depending on how many things are currently running on the computer. As we can see here, the program has finished. It says success. Go ahead and hit enter, and that will close the program. Now we can see a new file, which is a raw file, which is essentially the same as a raw image file. They're both the same file type. And so any program that can read a raw image file or a .dd file should be able to read this .mem or .raw file. And then to view it, you would follow the exact same process as before, where you would just open it with Access Data FTK. So now we're going to look at a .mem or .raw file that actually contains significant user information. And we're going to do that using a tool called Volatility, which can be found on Kali Linux. So go ahead and open your Kali Linux VM and go ahead and launch a terminal window. In the terminal window, you're going to give the following commands. You're going to navigate to user, share, and then volatility. Once you've navigated to this directory, go ahead and enter the following command, python, and then vol.py, and then -h. And this will launch the volatility system framework. You can see here that there are a lot of different options to be used within this particular tool, and you can definitely go through those. Those will help you to locate certain information within the live memory image file that you have created. In this case, we've placed a memdump.mem file in the home folder, and we're going to be using that to look at some different information. The following command will give you some very basic information about the system that was imaged. As you can see here, this particular command is called image info, and then this is the path to our memdump.mem file. Running this command will give you several suggested profiles. In this case, those that are suggested are either a Vista or Windows 2008 Service Pack 1 or Service Pack 2 operating system. Here we can see some other interesting data, such as when the image was made, and also the number of processors for the machine and the image type. In this particular case, we happen to know that the machine was running on Windows 2008 with Service Pack 1, and you can tell this by just analyzing the machine at a later date as well. In order to find more information about the SAM login or the username logins, we can use this command, looking at the Hive list for the specific profile. The resulting list shows us several locations of particularly interesting and important pieces of information. For instance, we now know the virtual and physical location of the SAM and security data. And we can use this to locate the credentials, or the hashes for the credentials, that we could then use to find the corresponding passwords. In order to extract password information from this memory dump, we need to know those locations. So essentially what we're going to do in order to create a hash file of the SAM data is we're going to locate the starting point for the SAM data information within the virtual space. So here what we've done is just copied the location from the first or virtual column for the SAM data and also for the security data, and we've put that here. Go ahead and click enter, and this will create a text file with the corresponding hash values for the SAM and security data. Now that we've created this text file, we can go find it in the root, and it's just called hash.txt. And if we open that file, we see a list of not only all of the users for this computer, but also the hashes of their corresponding passwords. So here we can see that the users on this particular machine included administrator, guest, student, probe, Waldo, and then another one called your name. And these corresponding sets of numbers and letters are the hash values that we can then use to find the passwords for each of these. In addition to finding SAM data and the corresponding passwords, we can also use Volatility to look at a list of processes that were running at the time the image was created. In order to do that, we're going to use a command called pslist or process list on this particular profile. This is a list of all the processes that were running at the time that the image was created. The PID and the PPID give you some interesting information about the processes. The PID is the process identification, and then the PPID is the parent ID. So if there was a parent process that launched a particular child process, that would be shown in this particular column. In addition to seeing processes that were running at the time the image was created, it's also possible to see recent console commands. These commands could include creating new users and the corresponding passwords for those users. Go ahead and run this command using consoles. Here we can see that some of the most recent commands included creating the user Waldo, and we can also see the corresponding password for that user. Additionally, we can also see the creation of the user your name and the password for that. Finally, it is also possible to see any services that were running at the time the image was created. Go ahead and run the command using service scan or SVC scan in order to see the majority of the services that were running. Volatility will give you a list of each of the services, along with the service name, the display name, the service type, and the service state as to whether or not it was running. It is clear that there is a large amount of data that can be recovered from RAM. That includes a large amount of data that would not otherwise be recovered from a regular forensic image performed on a hard drive. Not only can sensitive data such as password hashes and usernames be recovered in order to be cracked, but other data such as malicious or illegal programs and services that can be used as evidence when building a case file can be found as well. RAM collection and analysis is quickly becoming a pivotal part of forensic investigations, and therefore it is important that all forensic investigators understand the data that can be gathered and how to properly gather this data.